Correct. The Zoom is yours. Thank you.
Thank you very much for this opportunity. So, as mentioned, I will talk about potential applications of negative radiation pressure. Yes. So, for example, in these two-way quantum computers, yeah, I'm trying to move forward for a few years, but I have new approach, better approach now. So, medical, very interesting medical new applications, also in astronomy, astrophysics. So radiation pressure is just a vector. Yeah, so this is the simple cross product of electric and magnetic field. So we usually think about positive, yeah, being toward the surface. But it's not a problem to just reverse this magnetic field and getting negative, getting outward surface. Yeah, so and recently there are many articles trying to get, for example, negative radiation pressure in metamaterials, gain medium, kinks, in solitons. So here you would like to pull energy from excited resonators like atom. So what do I mean? So I think it's very good to think about the hydrodynamical analog, which is very similar to electromagnetism. The equations are very similar. So in hydrodynamics, we have something like photon, so wave carrying energy, momentum, and angular momentum. Yeah, so this is basically the photon. It's some energy carrying energy, some localized wave carrying energy, momentum, and angular momentum. And something very similar we have in hydrodynamics, for example, behind marine propeller. Yes, if it hits a resonator, it could excite a resonator. But we could also apply time symmetry and reverse the rotation of this marine propeller, getting now a pulling wave. Yeah, so we could reverse the momentum of this wave. So now, if you would hit the resonator, it would pull energy from excited resonator. So we need something like this in electromagnetism for various applications, and I think there is at least one series of experiments which we actually use it. So in electromagnetism, the simplest I think way is through synchrotron radiation, at least to imagine the situation. So we have electron traveling on a circular, let's say magnetic field, and it emits photons which excite a target. So we could again apply time symmetry, like for this marine propeller, just reversing the rotation direction of this electron or generate some charge. So now it should also excite some target, but kind of toward negative time. So returning to our time, it means de-exciting. Yeah, so it should have both the excitation in this direction, but also symmetrically the excitation in the opposite direction for the reverse trajectory. So mathematically, there are these two equations, symmetric equations. One is the absorption, depends. So this is the basic causality, causing to trying to excite the target. So it depends on the number of ground state atoms, and there is symmetric version, the stimulated emission equation, which now we try to de-excite atoms. So now it depends on N2, on the number of excited atoms. So why the formula is usually this N1 is much larger than N2, and N2 is usually tiny, so it's much more difficult to get the second because it also requires preparation of the target. Yeah, but generally you should have both. Symmetry suggests that you should have both this causality with absorption equation, but also with the stimulated emission equation. Like for this marine propeller, it both pushes energy into resonator, but also pulls from resonator. So yeah, so I need this kind of negative radiation pressure. So there are already very popular applications of stimulated emission. For example, the STED, stimulated emission depletion microscopy. So it uses two lasers. So one is to excite this tiny dot, and then the second laser which de-excites, causing de-excitation in this donut, getting finally even smaller dot. So improving the resolution of this microscope. Yeah, so it uses stimulated emission, but in positive radiation pressure. So I would like to have negative radiation pressure version. Would be much more practical for also for STED and for medical better scanners, better radiotherapy, literally to start tumor, or in astronomy, or for two-way quantum computers. We would like to build quantum computers on this symmetric formulation, like in a scattering matrix, that you have two amplitudes. We have state preparation, but also kind of post-paration. So symmetric version of preparation on the second. So we would like to literally pump photons through our chip, not only pushing to, but also pulling from, with positive and negative radiation pressure. having such two-way control, in theory, we could solve NP problems, have much better error correction. People are there are many problems with getting quantum superiority, and this way could make it much faster, mastering the two-way control of quantum computers. Okay, so here is the promised the most promising approach, which already has many experimental confirmations. So they get super radiance by effect, which looks like what I need. So they use these kind of chips with 2 or 3 diodes. So some are powered with forward bias. The voltage is as it should be, but some have reverse bias. There is reverse voltage for this diode. For forward bias, it is standard light emitting diode. It has tendency to emit. But for reverse bias, this is literally time symmetric version. Yes, we reverse electron flow through our chip. So now instead of tendency to emit, we change it into tendency to absorb. And it turns out this is not just passive absorber, but it actively helps with emission from the second one. And to get super radiance, they require this negative bias. Yeah, so it is not just absorber. It helps with it seems to help with emission of photons from the other parts. So, for example, thinking from a scattering matrix perspective, it means what is the probability of photon exchange, and it depends both on the emitter here, but also on the absorber here. Yeah, so we forward bias, we have this tendency to emit photons, but with reverse bias, we give the tendency to absorb photons, and this is also important to try to help to stimulate emission with the second part, what here has allowed for super radiance. Yeah, so I think this is the most promising approach. So just use diodes, but with reverse bias, which already have many applications, like very sensitive detectors, single photon detectors, the receivers for lead-to-lead communication. So for many applications, I would like to use again the forward bias and reverse bias. And for example, for scanning, put a patient between them. For two-way quantum computers, put a photonic chip between them. To both push photons to the chip, but also automatically pull photon. Yeah, so we have the state preparation, state post-preparation, and between there is a chip, the photonic chip for quantum computer. So another maybe argument is that they have this kind of intensity, luminosity curves, that there is positive, the super radiance, but then there is negative. So for a moment, the chip has tendency not to emit, but to absorb, and it's seen as negative signal. Yeah, so they often see negative signals, but usually ignore them. But I think they shouldn't. I think that the negative signal is also very important as literally this negative radiation pressure. Also in astronomy, I will show in a moment. Okay, so but the crucial part here is the CPT symmetry of physics, which is at heart of modern physics. If it would be violated, then we need to change the Lorentz invariance and everything. So I think nearly all physicists believe it's true. There are many microscopic confirmations. So the question is, what about macroscopic? What is sounds controversially that equations governing physics are practically the same if you go forward in time, but also backward in time. Yeah, so one can ask, what about the asymmetries like entropy growth? Yes, low thermodynamics. So the basic answer is that there can be a theory which is symmetric in equations, like the lake surface, but in solution the symmetries are broken, like with a rock here. Yeah, so it is not a problem to break symmetries of equations in a solution. So this rock for us is, for example, the Big Bang. Yeah, everything was localized, so the entropy was very low, creating the entropy gradient we call a second law of thermodynamics. But fundamentally, in equations, physicists believe there is CPT symmetry. So there are these two philosophies of time. So our intuition suggests this presentis, that there is this current moment and it evolves forward. But modern physics is based on this eternalist block universe, general relativity, quantum field theory, that there is four-dimensional solution already solved by the least action principle in the general relativity, by the Feynman ensembles in quantum field theories, and we travel through such already found solutions. And it, for example, is in this S matrix, We have two amplitudes, one from propagator from -infinity, second from +infinity. They meet in this moment, getting the Born rule. A Born rule allows to vary inequalities, which are intuitive for now, but physics is fundamentally symmetric, like in this S matrix, leading to very non-intuitive consequences. Okay, so going to these two-way quantum computers, so they try to build quantum computers based on this S matrix formulation, that there is this symmetric both preparation, but in theory we could also try to influence the post-paration. Like these two chips, forward and reverse bias, and we put the photonic chip between them. Yes, is there a question? Yes, so we would like to have literally have tendency to emit, tendency to absorb, and between them have a chip. Yeah. So if successful, in theory, they could solve post-BQP problems. Which contains NP problems. So and also much better error correction, error the resistance. So for electronics, it's trigger to get two-way control. We have a chip, electronic chip, and with battery we both push electrons to and also actively pull electrons flow. Yes, we have two-way control of the electron flow. Also for hydrodynamics, we push and pull fluid. If this fluid is a superfluid, they start building quantum computers on superfluid. So building something like this, connecting some superfluid quantum computer to pump, you'll get two-way quantum computer with two-way control. Much better error correction, able to solve NP problems. So the question is, could we do it for electromagnetism, which mathematically, again, is very similar. So maybe for microwaves, maybe finally for photons. And so we need, again, to push photon into and pull from. So from CPT perspective, like here, switching them, we switch the input and output. Yes, and for example, these settings could allow to do it. And for example, synchrotron radiation. So I think that there are ways to get symmetry of pushing photon into, which are used for state preparation, to get in CPT perspective this symmetric version of state preparation. Yes, both push photon and pull photon from the chip. So this one non-directional two-way quantum computers, much more powerful than current ones, solving NP problems, so maybe breaking current ciphers. And the medical applications, also extremely interesting. For example, much better scanners. So scanners, so we think about scanners based on this positive radiation pressure, but building medical scanners of negative radiation pressure, that would be much better. So let me try to convince you now. So let's imagine these simple settings of computer tomography. We have a source of photons, for example, synchrotron, and this is our patient. So it's subtract the number of ground state atoms on the go. Then there is a detector, which so we excite atoms in the detector. We can find how many were absorbed. Yeah, so we have this computer tomography, for example. Let's apply CPT symmetry to this picture. Yeah, so now you have to reverse the electron direction. So instead of this positive pressure, radiation pressure, we need this negative radiation pressure. Now, instead of absorbing the photons, they will be stimulated emission. So now we subtract not the ground state atoms, but excited atoms. We also need special detectors. So why it would be better to scan not ground state atom but excited atoms? Because the number is much lower, like 1,000 times smaller, the N2. So we would have much better transparency. Yeah, so if it's 100 times weaker, then we could easily make scan through human body. So we could in with non-ionizing radiation, so just in optical spectrum, we could map excited atoms inside our body. So instead of absorption coefficient, emission coefficient. Yeah, so this is focused on absorption coefficient. Here it's focused on emission coefficient. So assuming that we can do it, so there are many molecules already excited. So we could scan this way. So for example, this tryptophan, collagen, elastin, and NHDH, flavids. So for example, an NHDH is crucial for metabolism. So we could make this kind of scan for various these wavelengths, getting 3D two or three-dimensional maps of these molecules. So this is a novel information. So this is a complementary information to standard scans, non-ionizing. So you could do it without nearly any damage to the body. Also color, you could make it multispectral, use multiple color at once. So I think it could easily find some tumor or metabolic problems. Yeah, so my point is that when we think about positive radiation pressure for the scanning, using negative has lots of advantages. But we need to get both how to get this source of negative radiation pressure, but also we would need a special detector, which is originally pumped, and then we monitor its population. So it's much more difficult to also get such a detector. Okay, so besides scanning, also medical the radiotherapy, that we would like to use this negative radiation pressure to stimulate emission. So we could stimulate emission of, for example, of this NHDH, which is crucial for metabolism. So if stimulating this emission, we would degrade the NHDH. So literally, the local tissue would be starved. Yeah, so we could focus multiple such negative radiation pressure sources in the cancer tissue. Let's say speeding up the degradation 10 times, and for intermediate tissues for a fraction of percent. So it would be completely negligible. Yeah, so why now currently radiotherapy is like 50 sieverts, so it's completely deadly for the tissues. Doing radiotherapy with negative radiation pressure would be much more healthier. And as mentioned, the positive radiation pressure is absorbed by the ground state atoms, while negative radiation pressure is absorbed by the excited atoms. And the number is like 100 times smaller, so the penetration would be much better. So we could again in visual spectrum we could make radiotherapy just starving the let's say the cancer tissues. And choosing for which molecule. Also, there is, for example, the singlet oxygen. So there are many also metabolic, I think, conditions which could be handled this way. Okay, so let's go to astronomy. If you have any questions, comments, so please unmute and. So okay, so now another direction, astronomy. As mentioned, so we should search for the question is, are there cosmic sources of negative radiation pressure? Yeah, so if there are, there should be seen as negative signal that our telescope is rather sending photons than absorbing them. Yeah, so and it turns out that looking in the especially radio flux maps, they have positive and negative signals. So I have tried to ask people about. They said that there are artifacts. Yeah, so they ignore it. So usually it's like that engineers ignore experimental people ignore artifacts, and later it turns out that these artifacts are the most interesting. Yeah, so there are very clear maps. There is both positive and there are negative signals, and currently they are completely ignored. But I suspect there might be actual cosmic sources of negative radiation pressure. So the question is, what kind of astronomical object could have this negative radiation pressure? I think the most interesting would be black hole. So let me explore now. Okay, so let's think about black holes. Yeah, so there is this symmetry, CPT symmetry, with which black and white hole. Yeah, so white hole has only allows photons to go out. Black holes only allows photons to go in. Yeah, so CPT time CPT symmetry switches between white and black hole. So white hole would be a perfect emitter, could only emit. So we have only positive radiation pressure, would only influence this part, the initial state. So black hole is symmetric version. So it's a perfect absorber. It can only affect this way and linear effect. So if you change this part, the amplitude, the probability of exchange of photon would increase. So from CPT perspective, our black hole is a white hole. Should be very active, but in the opposite way. So not exciting targets, objects around, but de-exciting. Yeah. So while white hole would heat matter around, black hole symmetrically should actively cool matter around. Yeah, let's think about this symmetry. So for example, white hole should push with positive radiation pressure, emit photons, heat, acting with absorption equation on the matter around, form jet going out. So symmetrically, black hole should pull actively, absorb, cool, acting with stimulated emission equation around, with negative radiation pressure, should form jets going in. Yeah, so just think about symmetry. So they say there is this black hole information paradox that black hole do not exchange information, but they exchange just with negative radiation pressure, not positive. Yeah, so I think this is nonsense. If you think about, start thinking about this negative radiation pressure, also this black hole information paradox disappears. So they are very actively interact, but with negative radiation pressure. So let's take a look at some experimental evidence. So, for example, if there is active, so we would expect active cooling by black holes, symmetrically to active heating by white hole. So there are many these articles saying that it's surprisingly cold, that they expect something, but there's missing around a black hole. So this active cooling could help with. Also, there are not seen the intermediate mass black holes. So again, maybe this active cooling could make them in sweet spot of this making them less visible. And there is turns out that they know well that electrons have much lower temperature than ions, like 160 in the models that they are using. So this is exactly observation I would expect, that this cooling would be mainly for electrons. But they say this is mainly inverse Compton. So the question is, so the inverse Compton is that the photon, the low energy photon becomes high energy photon becomes a low energy photon, and some of this energy gets to electron. So the question is there also this stimulated emission from the surrounding? So, but it's very difficult to get it from the data. So I've talked with some astrophysicists, but it's difficult to confirm or deny it now. And again, there is tremendous grow. They grow faster than expected, and this active pulling, not only electromagnetic but also not only gravitational but also electromagnetic, could help with this faster growth. Then the formation of these swirls. Yes, some white holes should form these swirls outside. Black holes should form swirls inside. And indeed, this Event Horizon Telescope see that there is this swirling inside. So the white black holes have not only the jet, but also the local swirling, plasma swirling, that they call it. So there are many arguments that already indeed the black holes have this pushing. So they are not, they are also very active outside, and so maybe we could observe it, and to observe it, it will be literally negative signal. So maybe the blue regions mean that there are many black holes, maybe the intermediate black holes they are missing. Okay, so there are many articles claiming negative temperature inside black holes, negative pressure inside black holes. So the peer-reviewed or peer-reviewed, you can check them in the slides. So we usually think about matter with positive temperature, and positive temperature means that it has tendency to de-excite. Yeah, so it would like to emit photons. Negative temperature means tendency to excite. It would like to absorb photons. So this is exactly what we look for this negative temperature. Yes, like I have this balloon. If this is rubber ball, if you put it and you release, it would like to pull. Yeah. So again, so there are many peer-reviewed articles claiming negative temperature, negative pressure in black holes. What's exactly what I'm looking for? And again, it could be seen as negative signals in radio telescopes. Okay, so maybe some general picture, maybe for the discussion. So please interrupt me, so we can discuss any time. So let's think about the history of universe also from this perspective. So there was this Nobel Prize for accelerating universe, but especially last year there were a few counter arguments, both from DESI, that dark energy weakens, but also there is this revisit that the younger galaxies are dimmer, so maybe there are different. So I think it's not so certain that universe is accelerating. So maybe it could decelerate and finally get back to collapse. So the question is, so from CPT perspective, evolving from this perspective, this point backward again. So if it's again everything is together, so the entropy should be very similar as in our Big Bang. Yeah. So again, the entropy should be small here, because entropy depends on the temperature. So all the parameters here and here crucial are need the same. So in these big bounds, entropy should be again small. So entropy has to finally stop increasing and should decrease. So the entropy growth seems just a matter of solution we live in because of being close to the Big Bang, but being close to the Big Crunch, I think it should be reversed, the second law of thermodynamics. Evolving backward, everything should be evolving backward from Big Crunch. It should be very similar to our Big Bang. So, but between these low entropic regions, there will be heat death age. So nearly everything low entropic should be killed by this heat death age. So we shouldn't expect low entropic artifacts from here. Another very interesting asymmetry, I know for example, from Hugh Price, is so-called asymmetry of radiation. That, for example, now the circulating electron, they are mostly emitting photons. But so why is that? So Hugh Price explained that because there is now more absorbers than emitters, what sounds very reasonable. Yes, and in far future it could be reverse again. So in far future, our circulating electron could be in balance between emission and absorption, and finally could for us they could literally absorb photons while for this reversed observer, they would emit photons. Also, we could think about black holes. So now there is a tendency to form black holes, but evolving backward from big bounce, assuming it was, so it would be reverse again. So for us, the black holes created here, for us, we would see them as white holes. So maybe there could, if while the low entropic objects couldn't survive later this heat death age, these white holes might survive to our times, and maybe some shining dots might be the white holes. Okay, so another type of arguments for this pooling is the Anita anomaly. So Anita anomaly there is this detector in this balloon. And the problem is that it has seen a few many this kind of observation that seemed like going through the Earth and then making the shower here. So first they thought it was some tau lepton, but it turns out it is not possible. And now they say that all the standard model is disqualified. So we know that this object here couldn't be from standard model. They use some new exotic physics. They don't know where to search. So it sounds terrible. But maybe it wasn't pushing to air, but maybe it was pulling from above. So maybe you should think about some CPT symmetric. So people think about only pushing, but there is also symmetric pulling. So maybe again there was some event here, and it was pushing instead of pulling instead of pushing. So I think it should be explored, but again, it's very difficult to test it from experiments. Okay, so if there are so I have many auxiliary slides. So let me. So there are one of symmetric situation. For example, is this the Rabi cycles that we have laser, both causing excitation and de-excitation cyclically. Yeah, so there is kind of both way. And it has mechanical analog, just these couplet resonators with two resonators, and then literally exchange energy. And so photons go left, right. So we think about one directional, but in fact there is this coupling. This causation of photons works both ways. Also, we could think about the standing wave with semi-transparent wall, and the standing wave would cause both push and pull this particle. Yeah, so we think about pushing, but there is also symmetric pulling everywhere. And there are these synchrotron sources, there are these succeeding generations. So there is this synchrotron, Wiggler, undulator, finally free electron laser, and free electron laser finally gets super radius. So actually, the number of electrons improves the synchronization, the luminosity. So also the spectrum is much wider. So again, it seems that it's not that maybe the farther electrons also help with this simulated emission, because if you look about from CPT perspective on it, so this is just electrons on circle, and from CPT perspective, this again charges on sign line. So it sounds like maybe there is both this positive and negative radiation pressures. I think it's also crucial, especially for this super radiance here. So thinking about these electrons on circle, again from CPT perspective, it should also work, and it requires that there's both this pushing of photons, but also pulling of photons. Yeah, so it's very difficult how to avoid this symmetric version. But we think about only about this one, but from CPT perspective, there is only this one. So finally, it should be both this pushing and pulling, positive, negative radiation pressure. Okay, so there is this beautiful crab nebula. So maybe we should. The big question is where to search for this positive, negative radiation pressure. So from synchrotron radiation, I think it's natural way. So there is this asymmetry of radiation I have mentioned, that now electrons may lose energy because there is more, I think, more absorber than emitters. Yeah, and also Hugh Price say something like that, especially that we could increase the number of emitters. So there are now these top accelerators, that there are more emitters, and now the electrons gain energy instead of losing. So putting more emitters there, we can reverse this asymmetry. So it cannot be in equation; it has to be in solution. So I don't know any other hypothesis than just the asymmetry because of more absorbers and emitters. So what about other realizations? So maybe we could do it just with antenna for very different spectrum. But so the question is, could we make antenna resembling this kind of marine propeller? So I think this kind of this spring-like antenna is quite similar. Also, reversing electric voltage reverses the electron flow. So we should reverse the radiation pressure. So the basic test, I think, is just using one as impulse of one to try to excite this resonator, and then using reverse impulse to try to de-excite, to drain energy from this antenna. So again, I think it's doable, but in Poland it's extremely difficult to organize anything. So I wasn't able to. Oh, and there are also other experimental suggestions that there is both pushing and pulling. So I have found this kind of setting, that there is a laser, there is excited erbium here, and there is this circulator. It makes sense only if this laser also pushes and pulls the photons from this erbium. Yeah, so I think it's also this kind of effect now called reverse amplified spontaneous emission. So to summarize some possibilities, how to try to create such sources of negative radiation pressure, we should make symmetric version of the emitters. Yes, we should reverse the Feynman diagrams from this one, which improves chance of emission from absorption from the target to this one. Yeah, so to stimulate emission from the target. So, for example, for synchrotron radiation is relatively trivial, just reverse the rotation of electrons, but getting to synchrotron is very difficult. Another might be, for example, this pump, this proton pump. So usually it is used to shine, but we could reverse gradient, and now we have absorption to tendency to absorb. So it could be used in biology. So I wouldn't be surprised if some organisms would actively use this reverse this kind of mechanism to maybe to try to cool surrounding. And finally, for diodes, so usually we made tendency to emit. We need to reverse this tendency, reverse the voltage, to have tendency to absorb. And as mentioned at the beginning, this is not just passive absorber, but it helps if superradiator, for example, actually. Okay, so how to detect this negative radiation pressure? So the basic approach is having this pumped detector. So you need to pump to make the simulated emission work on our medium. We need to get this high N2. So this is the difficult part. It has to be pumped. So and then we could monitor the level, but maybe we could use this way, that there is a semi-transparent mirror and there is the actual detector, and this target of negative radiation pressure helps with emission. We could see on this standard CMOS CCD. Okay, so what is this negative radiation pressure? So okay, but maybe let me skip it. Okay, so maybe let's now go to more elaborate on yesterday talk by Tere. So maybe let's now go to more controversial part. So what about the time symmetry? There, so it is very close topic, but negative radiation pressure allows to avoid it. We have just this marine propeller-like pulling wave. But so in the quantum mechanics, there are many processes which have hidden retrocausality. We cannot use it, but there is clearly required. For example, this classical Wheeler experiment, that we have this very far object, and the question is, was it left or right? So if we use if our detector can distinguish them, then we get a classical pattern. But if we cannot, then we get the quantum interference. So there is completely different statistics, and this choice could be made for astronomical objects like years ago. So it already had to know if we will use classical or quantum detector, and what statistics to choose. So it suggests kind of retrocausality this years before. Or the right choice experiments. This is the nicest one I know by Wellborn. So we have two entangled photons, and they rotate polarizer here, and the rotation of polarizer here changes between classical and quantum statistic on the second arm. Yeah. So again, it sounds like if these arms are far away, then you change you can have retrocausality, because if this arm will be very much longer, then you could change the path to what was the classical quantum statistics. But it requires coincidence counter, which prevents the signaling back in time. So why the fundamental physics is retrocausal, kind of, we cannot use it. Yeah. But quantum mechanics at heart has this time symmetry, unitarity in scattering matrix. Yes, it's very symmetric, CPT symmetry. So yes, and this symmetry, as mentioned, there is this scattering matrix. Literally, one amplitude goes from the past, one amplitude goes from the future. Now they meet, getting the Born rule, which allows us to vary Bell inequalities. So to see this symmetry, I recommend looking at this just 0-1 range, this infinite potential well. If we think about it classically, Boltzmann distribution in space, we get uniform distribution. But we know quantum is sine square, yes, for infinite potential well. So if you use path ensembles of half paths from now to our past, or from now to our future, like only one amplitude here, we would get first power of the amplitude. You will get sine. But if you use ensemble, uniform path ensemble of infinite paths, then we get squares, because exactly like in a scattering matrix. One amplitude goes from the past, second from the future, and to get some value, we need to get it twice from the both amplitudes, getting the squares. Yeah, so the Born rule, I don't know any other explanation, comes from the time symmetry. So it's very deeply hidden. And having the Born rule, you can vary Bell inequalities, because I like to use the Mermising quality, which is much simpler than original Bell. So it says just tossing 3 coins at least to give the same. Yeah, so it's completely trivial, but using Born rule, we can validate it. So to derive it, so this is the mathematically. To derive it, we can use the Kolmogorov third axiom that probability of alternative of decision event is sum of probabilities. Yeah, so this is very intuitive, and using it, we write what is this scenario, this scenario, this scenario. Summing it, we get everywhere at least one. So whatever joint probability distribution you will use, the probability has to be at least one. Yeah, so we trivially get this inequality from Kolmogorov third axiom. But now the symmetry allows us to replace the Kolmogorov third axiom with Born rule. Now saying that the probability is no longer sum of probabilities, but is proportional to square of sum of amplitudes, which is completely different formula for the same question. So replacing Kolmogorov third axiom with Born rule, we can now validate inequalities which were derived with the formula. Yes, and this is the example that we have, for example, in Isaac model, you have a sequence of 3 spins which forbid the 3 up and 3 down. So we would like to put zeros in the trees here for violation. So we have a sequence of 3 spins, we forbid 3 up, 3 down. Now, if you ask for the probability distribution at the end of such sequence of 3 spins, we would get one sixth for all of them. But if we ask for the probability inside, we need to multiply the 2 amplitudes from the left and from the right, literally. We get the same formulas, we get the squares inside. And if you're using the squares, Born rule, we get 0.6, we get the variation. Yeah, so I hope I have convinced you that first of all, the squares are very non-intuitive. Maybe using shutdown calculator are intuitive, but in fact, they replace Kolmogorov third axiom. They give completely different answer to a very simple question, what allows us to validate inequalities derived with Kolmogorov third axiom. Yeah, so I see that we can see the Bell validation as literally the proof that in fact we live in this block universe, that there is this 4-dimensional solution, and the current moment is just in the intersection between the past and future, and both act with on this moment. This is very symmetric. We think about asymmetry, the Kolmogorov third axiom, but physics is symmetric, the Born rule. Okay, so also there are even more controversial experiments. So one is the 2003 article, observed negative delays. That here is the delay, so here is some setting, so before and after, and turns out that the delay for some parameters is negative. And recently, there is very recent, like a week ago, there was finally published, this Steinberg's group, negative time evidence, the claim that the photon spent negative time inside this rubidium cloud, and it was published in PRL recently. So here is the date plot. So here is with post selection and without post selection. So we see that even without post selection, there is already some reaction before the impulse. So here's the impulse. So they say the photon spent negative time. So like the photon went forward in time, then spent negative time and go forward in time. But this is completely non-physical. Yeah, so like disappearing and appearing negative time. What is physical is the stimulated emission, which is the CPT analog of this absorption. So have reverse delay. So instead of this spending negative time, I think we should think about the stimulated emission. Yeah, so I think we don't need magic to explain it. Just use stimulated emission as CPT analog of absorption. So then, and another nice topic that tachyons. So again, so maybe I also was very skeptical, but thinking about just very simple models like Sine-Godel model. So Sine-Godel model is just lattice of pendula. Yes, we have springs, we have the pendulums connected by springs, and they want to be go down, but there is also down to pi further. And this switch between one and the second minimum has a minimal energy, is massive, it behaves exactly as particles. Yeah, so here is such king. But now having such solution to this extremely simple equation, we could switch x and t, getting still a valid solution. But now this switch would be not localized in space, but in time. So this is a still valid solution. And this is literally a tachyon. So generally, tachyons are allowed by field theories. However, this switched also reverse the potential. So while here it was in the minimum of potential, now it's maximum of potential. So that's the difficult part. You would need to make the field around the maximum potential. So they say, for example, that just for inflation, the Higgs potential was in the local maximum in the center, and then it could propagate faster than the speed of light. It's because of this tachyonic explanation. And there are also for superradiance, also the medium is prepared in the maximum state, yes, the maximum potential. And there are some articles claiming that the collective, these quasi-particles, this tachyon, this quasi-particle can travel faster than light. So I think so we should be more open to this kind of solution, especially looking at inflation and these kind of experiments for superradiance. Okay, so finally, to refer to yesterday's talk of Terry. So yes, as Terry mentioned, there are these symmetric versions. Yes, so I especially recommend this Rosen 1977 article. So in Maxwell, we think about the retarded solution, but in theory there can be also plus. Also for gravitational waves, usually the retarded solution, but it could be also both the electromagnetism and general relativity are time symmetric theories. So we choose the retarded, but we don't know. In fact, we should be more careful. They might be advanced solutions. And yes, Wheeler Feynman, as Terry mentioned, assumed this 1/2, 1/2. But this is definitely wrong, because 1/2, 1/2 means that there will be no spelling. So 1/2, 1/2 means that they would be circulating infinitely. The same amount of energy would be absorbed and emitted. But they are in spiraling state. Yes, so they're spiraling and emitting energy. That means that definitely they're more emit than absorb. So definitely the retarded are stronger than advanced. However, we assume there are infinity stronger, but maybe it's not infinity. So maybe it could be, let's say, 0.99 retarded, 0.01 advanced. So the question is, so these assumptions that they are only retarded. We should finally test it experimentally. I have written this archive to propose this kind of tests. And there are many suggestions that indeed there might be already. So let's go here. So most events, gravitational wave events, come from orbiting. You have two objects which are orbiting, but orbiting both if you evolve forward in time, but if you also evolve backward in time, this is still orbiting. So the same equation requiring them to emit gravitational waves say that they should also emit gravitational waves, but now advanced. So and LIGO just see lengths, and lengths are time invariants. So if there are advanced wave, LIGO should see them, should see both retarded and advanced. So now seeing an event, they automatically assume it is retarded, but in fact it could be advanced. So I think it should be finally tested, discussed. Are we certain they are advanced? So among 400 approximately events observed so far, there was only one having retarded counterpart, electromagnetic counterpart. The remaining 399 could be in theory advanced. So we need to search for other arguments, trying to ask the question: are they retarded or advanced? So there are other arguments. For example, some events look too early to be retarded. For example, they say there is this black hole mass gap, 50 to 120 solar masses. It means that the black hole couldn't be created by just collapse. It needs to be merger. So merger need much more time. They need to form first, then meet again. And turns out that there was event with two such black holes inside this mass black hole. So both of them. So this is extremely unlikely, and it was extremely long time ago. So maybe it was not retarded event, but advanced, giving it much more time. Finally, there is another type of arguments that for in pulsar timing array, they see literally, they call it the vibrations of the universe, and which were they say that they were created by supermassive black holes. However, they say the up to our knowledge, it's insufficient number of these supermassive black holes, so we need more. So again, why to think only about the retarded? Maybe you should also include the advanced supermassive black holes. Yeah, so there are many arguments that some of events observed by LIGO might not be retarded, as everybody assumes, without any questions, but they might be advanced, and I think it should be finally seriously tested. So we could also do it electromagnetically, but for electromagnetic, again, we need to reverse. So it would be not positive signal, but a negative signal. And they observe negative signals, but they ignore them for now. And it would need that the antenna, the amplifier is excited. Yeah, so it needs excited receiver. Usually the amplifiers are cooled, what prevents such observation. So maybe we should also think about special amplifiers for telescopes, which are artificially excited to be better for to observe negative signals, for example, from black holes. Okay, so maybe going to that. Okay, so another maybe consequence of general relativity. Yeah, so for example, I've mentioned that for tachyons, I need to reverse time and space, so purely mathematically. But general relativity says it's actually done below the horizon of black hole. Yeah, so literally the light cones are rotated 90 degrees. Yeah, but what if these light cones would be rotated twice farther? Yes, so we have a light cone and we rotate it twice farther. So literally switching past and future. So in theory, it could be allowed by non-orbitable wormhole, like this kind of. So we have could literally switch past and future. If we would travel through to such wormhole, our past and future would be switched. So for example, this preparation and post-preparation will be switched, as we need for two-way quantum computers. There will be the scanners, standard scanners of emission coefficient would becomes the absorption coefficient. Yeah, so the scanners would work as I require for external patient. Yeah, so if there is a scanner in such rocket and patient outside, it will scan not absorption coefficient but emission coefficient. So laser will cause this not positive but negative radiation pressure, absorption emission. Yeah, so in theory, general relativity allows all these effects, negative radiation pressure are allowed by general relativity, as it allows to rotate light cones. So usually about 90 degrees, but in theory it could be also 180 degrees. So okay, so to summarize this part, so the question is, so for hydrodynamics in theory, we could have four possibilities. The standard retarded positive pressure wave, as we think about photons, the basic ones. But we could reverse this rotation. It would have negative radiation pressure, but the delay would be later. So this is retarded negative radiation pressure wave. And having this kind of wave, we could already solve NP problems with two-way quantum computers. I have a few slides, but I can finish now. So for two-way quantum computers, we just need the pump. We need both to push photons through and pull them from. So we don't need advanced waves for two-way quantum computers. But having advanced waves, for example, if from this rocket going to this non-orbitable wormhole, now the wave from this propeller would go for our past. This would have negative delay. So if this is inside the rocket. So having this advanced wave, you could build a much better time computers, augmenting classical computers. Already classical computer could solve NP problems. For example, we could transform NP problem into search for a fixed point of a loop, and we just have to send the output to the input, and now the least action principle should solve our problem like that, should be already solved. Yeah, so to summarize, both them, we think about this one, but both just negative radiation pressure allows to solve NP problems with quantum computers, but having advanced waves could solve NP problems with classical computer already augmented. Okay. Okay, so two-way quantum computer. So maybe very briefly, so we have preparation and post-paration. So for example, so we had this team. We had X prize, but we couldn't convince experimentalists. Poland is extremely difficult. So for example, so one approach, but more difficult, is by thermalization. So thermalization sounds so. There is a basic way to state preparation, just wait in low temperature. So, but we can wait before, but we could also wait after. So if you wait after, then from CPT perspective, we wait before. So the suggestion that maybe just waiting after could also allow for thermalization, for symmetric version of state preparation, but it's difficult to test even some. And there are other estimates. So the much better way are these pumps, these positive negative reciprocation approaches. Okay, so generally there is some if state preparation by some impulse, we have to just reverse this impulse, maybe for example for silicon quantum dots. So finally, having such two-way quantum computer. So here is by Grzegorz Szelusta article showing that the resistance to noise will be much better. So the blue one is the two-way quantum computer is much better resistance to all kinds of noises. So such two-way quantum computers, because of having two-way control, would be much more noise resistant and also better error correction. So here is for NP solver. So some basic approach for NP solver could be just like for Shor, but instead of measuring the qubits from the classical function, you just enforce them. Yeah. So for example, for TSAT, we have the superposition of all the inputs. Then we ask for the alternatives. Then instead of measuring them, we would like to enforce them to be true, and it should restrict to the superposition to only solving our NP problem. So in theory, having two-way control, that's positive negative bias, for example, we should be able to solve NP problems. So we should think about post-quantum cryptography, yes, which currently is only focused on the Shor and Groover, but it might not be at the end. I think we should also try to build a next-gen post-quantum cryptography, which is resistant at least to NP solvers, quantum NP solvers. And there are various ways to do it. For example, enforce initialization, that we having a key, we cannot just use it to decode the message. We need to use it to prepare the actual much larger decoding tables, which will be used to decode. And so it makes it resistant both to brute force and to quantum computers, because the superposition would need to survive this preparation of these large coding tables. So there are ways to do it, but nobody cares. So now, but if maybe somebody is already using some ways to solve NP problems, and I think we are completely not prepared, and I believe you should be. And so this is some summary, various applications, various realizations. So maybe let me finish here. So thank you very much, and sorry for that. So I've tried also to organize it in synchrotron in Krakow, but it's quite difficult because it would require to use electron trajectory for use the stations for reverse electron trajectory. So it would be across the current station. So it's completely technically impossible to do. Another way is we're trying to add some mirrors, but it's also extremely difficult to put there. And finally, they promised me that when they will replace this magnet, they will make some windows for this kind of test. But I don't know, it might take years. So convincing synchrotron people is super difficult, because everything takes years there. So but this diode approach, yeah. So this positive negative reverse diode is much more promising. So it sounds simple, but I've tried for half a year to do it in Krakow, in Poland, but it's not successful. Convincing anybody is very difficult. So thank you so much.
Thanks. Thanks, Eric. Thanks for the talk. I do not see questions on the chat, but maybe someone would like to unmute and ask a question.
We can talk about yesterday talk from Terry, yeah. So yeah, so if you are looking for advanced waves, so this is one direction. Yes, one direction is taking a look at events of LIGO and trying to make the question: are they retarded or advanced? Currently, they just assume they are retarded. We should try to ask this question. seriously. And this is a very difficult question to ask. So one way to distinguish them is having electromagnetic counterpart, but this is only one for 400. So far we don't have. But in the future there might be events which we are certain there should be electromagnetic counterpart, but we don't see anything. I think this would indicate this is advanced event. But these are difficult questions, and we need collaboration with gravitational wave people. Another way to search for this advanced wave are these negative signals that they already see. Sorry, my computer
Can I
is.
ask Dr. Duda?
Yes.
Can I ask a question? Yeah,
Sure.
there's something that was quite interesting. On
Yes.
one of your slides, you made a comment, like a question mark, about the gravitational pressure. So is there a possibility of existence of negative gravitational pressure?
Yeah, so it would be very similar for electromagnetic pressure. So for electromagnetic, for observation, so I would expect negative signals in, let's say, these radio Fuchs maps, like the
No, I
blue.
didn't mean electromagnetic. I meant gravitational.
So for gravity,
Gravitational.
I don't think so. The only way to observe, so no, there are various ways. So one way is LIGO, and LIGO just measures length, and the length is invariant to time symmetry. So LIGO, if there are advanced waves, LIGO should already see them. Yeah, so I don't know how to measure gravitational pressure, positive, nor negative. There are another way to measure is that there are these pulsar timing arrays. So and again, pulsar timing arrays I think should see both the retarded and advanced wave. And there are suggestions. They say that the observed vibration of the universe requires supermassive black holes, but then the number is insufficient. So my suggestion is that they only consider the retarded waves, but maybe also include the advanced sources. But for gravitational pressure, I don't think it's measurable in near future. But it should be very similar. We should general relativity is time symmetric theory. We could
Yeah,
both
thank you.
Yes, general relativity. We usually think about Euler-Lagrange forward, but in fact, it is solved by the least action principle, by these Einstein equations, yes, which are for least action principle. And we could also solve them for the Euler-Lagrange for negative time because they are symmetric. So orbiting masses should, if as they are emitting gravitational waves, so also we could use Euler-Lagrange back on time should also emit gravitational waves. So some of events observed might be advanced. We should test it. Show that they are retarded, not just assume as they currently do.
Jerry?
Yes.
First of all, I love your emphasis on CPT's symmetry all the way through this. I think that's just a really powerful principle, and I could think of I could think of dozens of questions to ask on individual slides. But one, well, just focusing on one. When you mentioned Norte in 2024 with his negative temperature just inside the event horizon, I was looking at his paper. Is he arguing that singularities do not exist because of this? Or I was a little fuzzy on, I tried to interpret it. He seemed to be saying that, yes, that's the slide I was thinking where
I
they,
read it a year ago, but I don't remember the details. But here's his main diagram. Yeah, so generally, we think about positive negative pressure. In fact, they meet in the infinite temperature. So first there is everything is the lowest state in the minus zero. Then everything is the excited state in plus zero.
yes, that was the figure that was the specific figure I was thinking of from his paper. Yes.
I don't know about singularity there, but
Yeah,
generally, here is tendency to emit photons. So if something is excited, it wants to emit. Here is tendency to absorb photons. So this is reverse tendency. So here would be positive signal. Here would be negative signal. Yeah. So if you have an emitter here, it should stimulate emission from this emitter.
okay.
So this is exactly what I need for this negative radiation pressure. So I think black holes could be observed by focusing on negative radiation pressure. Why currently they think only about positive radiation pressure?
Yeah, and that is a fascinating concept. That's interesting to think about, and the implications of that. One thing you were talking about the CPT symmetries. I don't recall. Have you ever considered dual universe models as an aspect of CPT symmetry, not the Turok type approach? Just curious whether you ever thought about it, because the way you look at it is interesting. I'm curious what your thoughts might be on that.
Yeah, so I'm also thinking so. From one side, I think the collapse is much more aesthetic, but also there are these suggestions that the acceleration seems to weaken, and finally my collapse, making it very symmetric. So we can use this least action principle Feynman ensembles that we have solution. We have the boundary conditions here and here, and the universe, history of the universe is a result of action minimization between these boundary conditions or the Feynman ensembles.
Now, dual universe does its own version of cyclic, but it's a different version of cyclic with a different higher dimensional thing. Eventually, the two universes curve back and collapse into each other again.
I don't know any arguments for or against. I think we are too far for the. I don't like questions. I cannot completely answer. So
Okay,
I know.
right. Thanks. Lots of interesting things in your slides, and thanks for the references, by the way. I've downloaded about 5 papers just going through your presentation, so I appreciate the links. It gives a good way to check out some of the details as you go.
Lots of links here, yes.
All right. Do we have more questions to Dr. Duda? No, then I think we can finish for today. Helen, what do you think? Or do we have some questions on YouTube maybe?
Let me check. I don't see any question on YouTube.
I would make one additional comment. I think it was your slide 30 about quantum computing. I just think that's a lot of interesting potential where you're going through that model of advanced and retarded waves for quantum computing. I think the thing is that it, but
Okay, so the two approaches to quantum. Yeah, so that the question is that negative radiation pressure is sufficient. Yes, so this one. So there are 4 possibilities. I'm not certain. Okay, so I'm sorry.
see, slide 30 was. I just remember slide 30 in particular. I thought was interesting for its quantum.
Slides.
A different way of analyzing. Yes, yeah, analyzing quantum computing.
Yeah, so now we are focusing on this positive radiation pressure. So having just negative radiation pressure, like this marine propeller, would already allow to solve NP problems with quantum computers. Yes, by both influencing the state preparation and post-preparation, but initial and the final state. But having advanced waves, we could also solve NP problems with classical computers by enforcing physics to solve our fixed loop problem.
Yeah, that's an interesting thought. Thanks.
Okay. So post-selection, yes. So the post-BQP, I got a question. So the post-BQP, so this is very similar to post. Yes, two-way quantum computers are very similar to post-selection. So post-BQP solving using post-selection. But the question is, what is post-selection? So now you think about post-selection as just measuring and discarding all irrelevant. However, here I'm thinking about physically enforcing the final state. Yeah, so not only enforcing the initial state by the state preparation, like this standard laser at the beginning, but also enforcing the symmetric way, enforcing the final state by this, let's say, reverse bias laser at the end. So try to literally pump photons through our chip, pushing and pulling from. Yes, like these two positive and negative bias and chip between them. So having them, indeed, we could solve post-BQP containing NP problems. So this is very similar to post. This is very similar to post-selection, but instead of doing it logically by discarding, you try to do it physically by enforcing the final state by reversing the process you have used for state preparation. Yeah. So So if for state preparation you have used one process, then you use reverse process to enforce also the final state. Like these pump-like computers.
All right. Do we have more questions to Jarek? There's another question from Ankita. Can the model be mapped to known classes like post-BQP?
So this is exactly post-BQP, done replacing post-selection, logical post-selection with physical post-selection, you can say. Yes, but the class is post-BQP. So there are some, I also have some concrete realizations how to do it. So like for TSAT, as in Shore, you prepare the superposition of all inputs, then use classical function, for example, as these alternatives of triples. Then while in Shore you would measure it, in two-way quantum computers you can enforce it. Like post-selection, but literally you reverse process used for preparation. Yeah, so you could go do NP in theory, maybe also higher. Also, there is better error correction. So, for example, you could enforce that you to use superposition of only code words of some classical error correction. So it allows to solve NP, have better resistance to errors, and allows better error correction. So reaching two-way quantum computers would be a big jump in the possibilities. No, and we should prepare for that because current post-quantum cryptography might be easily broken. We should think about post-quantum cryptography resistant to quantum NP solvers. Thank you.
Okay, thanks. Thanks, Jarek, and thanks, Ankita, for asking. Do we have more questions? All right. If not, then I think we can finish for today. So, Jarek, thank you once again for a great presentation as always. And we thank all the participants for staying with us until the end. Thanks for all the questions. And hopefully the video recording will be available on our YouTube channel. Hope to see you next time on our next meetups.
Thank you. Have a nice Sunday and see you next time.
Thanks.
Thank you, Jack. Very interesting. Very interesting.
Okay.